Welcome to the TEOCO podcast, where we discuss the intersection of telecom, technology, and innovation. Today, we will be speaking with Nishita Hathi, Product Director at TEOCO, all about how crowdsourced data can be used to help plan and design 5G networks. Welcome, Nishita, and thanks for joining us today.
Thank you, Barbara.
Can you share with our listeners a little bit about yourself and what your role is at TEOCO?
Indeed. I am the product owner of TEOCO's network planning and design suite of tools called the Asset Suite. The Asset Suite helps operators accurately design their networks in order to ensure that they optimize on their CapEx and their OpEx spend. At present, my focus is primarily on ensuring that we have the right capability in the Asset Suite to help our customers around the world roll out 5G networks in an accurate and cost-effective manner.
All right, sounds great. Thanks. You sound like a great person for today's topic, which is all about crowdsourced data and using it to help design and plan 5G networks. But before we really dive into the nitty-gritty of things, can you explain for our audience what crowdsourced data actually is, kind of at a high level?
Yes. So in the context of mobile communications, crowdsourced data is data collected through applications on smartphones. So every time a smartphone user uses that particular application, certain data gets collected in the background. So this data is typically information like the location of the phone, some information on the network condition, and potentially some information on device or the applications being used.
Okay, interesting. So I know that 5G networks really are a lot trickier to design than some of the other technologies of the past, like 3G or 4G.
Yes.
So what are really the benefits of using crowdsourced data when planning and designing a 5G network?
So crowdsourced data is more granular than some of the other sources of data that we have available to us for network design. And this granularity is very useful in 5G network design because of the increased complexity, as you just mentioned. So to elaborate on some of this, 5G introduces new services, new devices, and new spectrum. In terms of services, we will have services like e-gaming. Looking a little into the future, we will have connected cars and even remote medicine. When we talk about 5G devices, it's no longer about just mobile phones in the network. We will have massive machine type communication. We're already seeing drones in the network. And again, looking a little into the future, we will have connected cars. So all these services and devices have different requirements from a radio perspective. So when it comes to network design, we need to be able to accurately model the geographic distribution of these different devices and services in order to optimally design the network. And that is what the granular crowdsourced data allows us to do. Also, in addition to introducing new services and devices, 5G also introduces new spectrum in the high frequency bands, the millimeter wave spectrum. We've not had to worry about millimeter wave networks before in 3G and 4G. So it's something new for us in 5G. In the case of millimeter wave networks, the cell radius is quite small, typically of the order of about 200 meters. So in order to plan millimeter wave networks accurately, we need to understand where the traffic demand is at a much more detailed level. Getting the site placement incorrect by 100 meters could result in loss of CapEx, not to mention unhappy subscribers. So once again, granular crowdsourced data can help us with accurate identification of site placement, particularly for the millimeter wave networks.
So you mentioned a little earlier about this data coming from mobile apps and things. Can you give us a little more information about that and like how it's actually gathered?
Yes. So there are a number of crowdsourced data providers out there, such as Ookla, OpenSignal, NPerf, to name a few. And typically these providers offer a service such as speed test in return for collecting the data in the background. In terms of the information that they collect, it tends to vary somewhat from provider to provider. But typically, these applications collect information such as the location of the phone, the state of the network at that point in time and at that location. And this is generally in terms of network KPIs like signal strength and throughput and latency. In addition to these crowdsourced data providers, social apps, social media apps such as Facebook and Twitter can also collect some subscriber data in the background. So all this data that is collected by these vendors is then anonymized, and it can then be shared with network operators for various use cases, such as network planning and optimization.
So how is all this information better than what operators have been using in the past and still are today?
So in terms of what operators have been traditionally using, they have a number of different ways in which they can collect information about their network. A few examples include PM stats from the OSS, geolocated measurement data, call data records, and more general information like census data and population data. What is better about crowdsourced data is that it can provide operators with information about their own network as well as their competitors' network. And also crowdsourced data is GPS based, so it provides more accurate location information relative to some of the other sources that I just described. But I would like to add one caveat there. Because we can only collect crowdsourced data for users who have chosen to install these apps on their phones, we do not get a full picture of the network. However, as long as we get a certain percentage of subscribers using these apps, the data is statistically significant for us to use in network design.
Okay, so I'm assuming you're pulling in all this data from all these different sources, but then how do you actually put it to use?
So there are a number of different use cases for crowdsourced data when it comes to network planning and network design. The core use cases focus around service and traffic modeling. So let me give a few examples. Crowdsourced data can be used to help identify traffic hotspots, so identify areas where there is significant traffic demand. It can also be used to help identify areas where there is poor service, so where the signal strength that is being reported by these apps is lower than a certain threshold. One of the key differentiators of crowdsourced data is that it allows operators to do competitor benchmarking. So identifying areas where the competitors are stronger than the operator in terms of different KPIs like coverage or latency or throughput. So all this information can be used in tools such as the Asset Suite to accurately design and optimize the network. So when we're looking at initial network rollout, for example, as with 5G networks at the moment, this information helps identify the best locations where to place 5G sites. And also it helps identify a prioritized list so we can create a strategy on 5G rollout. When we're looking at existing networks, this information allows us to identify which sites need to be optimized. So whether to optimize, say, antenna parameters to improve coverage in a given area, or whether to add, say, MIMO or a new carrier or a new site to improve capacity in a given area.
Okay, so it sounds like this data, that this data and these tools, I think you said Asset Suite is TEOCO's solution.
Yes.
Is it used just at the initial phase when you're designing a network, or it sounds like it's something that could be used going forward, like an ongoing basis? Is that the case, and is that needed for 5G networks?
Yes, it can be used on an ongoing basis. So in the case of 5G networks, for example, as the traffic on the 5G network grows, operators will have to add new sites, or they'll have to optimize their existing 5G sites to meet the growing demand. And crowdsourced data can help them accurately model that growing demand. When it comes to 4G, 4G will coexist with 5G for the foreseeable future. So network operators will have to ensure that their 4G networks are also optimized to maximize on their 4G CapEx and OpEx investments. And again, crowdsourced data can provide a valuable input to that optimization process.
All right. Well, it sounds like some cool stuff definitely happening on the 5G planning side of the business, and I'm sure that there's a lot of interest out there right now. Timing is critical for a lot of operators. This could be certainly top of mind. So is there anything else that you want to add, Nishita, before we say our goodbyes here today to our audience?
No, thank you very much for inviting me to this podcast, Barbara.
Oh, our pleasure. It's been a great chat. So for our listeners out there, thanks for joining us. If you've enjoyed today's discussion, please be sure to share it with your friends and coworkers. You can visit our full library of topics at TEOCO.com or really wherever you find your favorite podcasts. And also, if you have any follow-up questions for Nishita on the topic of 5G planning and network design, or if you even have suggestions for future topics that you'd like to hear us talk about, please send your comments to us at podcast@TEOCO.com. So thanks again, everyone, for joining us. Thank you, Nishita. This has been a great discussion. Thanks all. Take care, and I hope you join us for future discussions. Thank you.